Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we'll talk about the reaction mechanism. So what is the reaction mechanism? Okay, some reactions could happen in one step. Like if we have A and this one will convert it to B, this is the reaction. It will be occur in one step for where A will be directly converted to B. But some reactions will go through different steps or sequence of steps. So if A will be converted to C, and C will be converted to B. So we have two steps to reach the product. If we have more than one step to reach the product, so this would be called the reaction mechanism. So the reaction mechanism is just like the sequence of the steps that we have to reach the product. If we see here, we have this reaction, and this reaction is NO2 plus CO will yields NO plus CO2. So this is the reactant here, and these are the product. So the reactant should form the product, but actually it will form the product in two steps. The first step, 2 of NO2 will react together to form NO3 and NO. So one of the oxygen will move into this one to form NO3 and NO. And then NO3, this one will react with the other reactant, which is not used yet, which is CO, to form NO2 and CO2. And this is the product here. So these are the product. So if we have two steps here, so these two steps will be called the reaction mechanism. Each step in these steps will be called the elementary steps. So for each one, we will call it elementary step. So it will be called elementary step or elementary action. So for each step, we will call it elementary action or elementary step. And for each one of these, we can write rate reaction for each elementary step. So we can use the equation for each one of them to write the rates for each one. So if I want to write the rate of the reaction for the first step, which will be calling R1, so this will be equals to K1 times the concentration of the reactant, which is NO2, and we have 2 NO2, so it will be written twice, or it could be written like K1 times NO2 to the power of 2. And if we want to write the rate of the reaction for the second step, R2, this will be equals K2 times NO3, the first reactant, times CO. So for each step in the reaction mechanism, we can write the rate of the reaction for each one of them. But of course, it will not be always like the rate of the reaction. Okay, let's go here. Before we talk here, we need to differentiate between two things. Okay, so before we go for this one, we need to differentiate between two things. The first one, which is intermediate, and the second one is the catalyst. Okay, so what is intermediate? If we again go for the reaction that A will form B, this is the overall reaction, but this one will go over steps. What is the step here? A will try to form C, and this C, just like a new structure, a new formula of A, where they can go to form B, which is a product. So we have something like transition state between A and B, and this transition state just helping A to form B, because it will be easier for them to transfer to C first and then C to B. So C here is not one of the reactant, is not one of the product, but it's just like a transition state between the reactant and the product. This will be called the intermediate here. So the intermediate is just a new structure. It wasn't found in the reactant. So this one is just new structure. This one wasn't found in the reactant. This is the most important one. You can find this one in the reactant, and actually after the reaction finish, you will not find this one because it will consume, it should form the product. So you will not be able to find it in the reactant or in the product, okay? So this is the intermediate. But for the catalyst here, let me erase this one. But what is for the catalyst? So this is for the intermediate, but for the catalyst, actually for the catalyst, A should go for B and form B. So this is the reactant and this is the product here, but A needs some help because it can't form B or the reaction will be very slow. So we need to put something with A in the beginning of the reaction to help A to form B. So this will be called the catalyst. So we will put D here. So D will help A to form the product, and then D will not be consumed, so you will be fine. You'll find D after the reaction, or so the catalyst will be put or appears in the reactant, and also after the reaction will be finished, it will be found in the product, because the catalyst will never be consumed. It just helps the reaction to be more faster or to be faster. Okay, so D will be, or the catalyst will appear in the reactant, and then it will be appear in the product, but the intermediate will not appear in the reactant or in the product. It will be only consumed, or just like transition state will be found in the middle of the reaction. Okay, let's solve the questions here. So what is the intermediate substance in this reaction? So we have a mechanism, and this is the mechanism. We have 3 steps for this mechanism, which is the color. Okay, so we have 3 steps. This is the first one, the second, the third. Which one is the intermediate? So we will start, this is the reactant, and this reactant will form new structure, C4H9 plus Br minus. Okay, and then C4H9, this is not this one, is plus H2O will form this one. And this new structure, okay, this will be consumed here to form with H2O to form the product. Okay, there are 2 way to find the intermediate. First, you can add all the reactant or the product for the 3 steps or the 2 steps to write the overall reaction. If you try to find it here, so when we find the substance in the product and in the reactant, you can cancel this substance. Okay, so here we can cancel this one. Okay, this is the only one we can cancel out, because this is the only one that was repeated in the reactant and the product. Okay, so this should be the intermediate. So the intermediate will start to appear as a product. So this is the first part. You will the first time you will see as an intermediate, you will see it as a product in one of the steps, and then this product should be consumed in the second step or the next step as a reactant. This is the intermediate. So the intermediate here should be C4H9OH2. Okay, so why we choose this one as an intermediate? Because this one was appear as a product. It wasn't in the reactant. It will just appear as a product in one of the steps, and then it will consumed in the next step. Okay, let's see the next one. We have also 3 steps here. 1, 2, 3. Okay, so for I2, it will convert it to 2I, and then I will react with H2 to convert it to H2I, and H2I will convert it with react with I to convert to HR. Okay, let's see, this is the reactant here, and then we will have a structure at 2I. If this 2I were consumed in a next step, so this should be an intermediate. Okay, let's see that this one, 2I, yes, we started with 2I here as a reactant, and also we use 2I as a reactant here. So it means 2I, just like a transition state, it helps their product or the reactant to form the product. So we will use 2I. So this is the first intermediate here. Okay, what else? Okay, let's see that we have here H2. Okay, so H2 is a reactant, so it should never be intermediate. H2I, yes, this one is a product. If this one will be consumed in the next step, so this one should be an intermediate. So let's see. Yes, we have here HI. So H2I is also an intermediate. So again, we will add the 3 steps. Sorry. We will add the 3 steps, and if you can cancel some of the substance, so the substance will be canceled out, and this substance will be like a product and then a reactant, so it should be an intermediate. So this one, 2I, will be canceled with the 2I, and this one appears first, or you can see it first as a product, and then it will be consumed as a reactant, so this is an intermediate. And H2I, this one also start to appear or as a product and then consumed as a reactant, so this one is an intermediate. Okay, so if we have a reaction mechanism, we'll have different steps in this reaction mechanism, and each step will take a specific time. So some of the steps will be slow and some of the steps will be fast. Okay, so we will go for, if we have a step 1, step 2, like this one, let's go here. So this one, sand will go down here. So this one should be considered as step 1. And this one will be considered as step 2. So we have 2 steps here for the reaction. Okay, we can see that for step 1, this one is the narrow, this one is narrow, so this one will take long time or longer time to move the sand from this part. So it means this one will take the longest time here. But this one is not narrow, so this one is large, so it means it will take less time. So we have two steps, and each step has different time. The step with the longest time, the step that will take longer time than the other one, this will be considered as rate determining step. So which one is the rate determining step? Is the slow one. So in each mechanism, he will write next to each step, he will write this one is slow or this one is fast. Okay, mainly you could find only one slow step in each reaction or in each mechanism, because this one will be only the rate determining step. So if you have many steps, one of these steps will be the rate determining step, because this one will take the longest time. So this one is the controlling of the reaction time. So this one will be called the rate determining step. Okay, so if we know that this one will be the rate determining step, so actually, if we know that this step will be the rate determining step, so we can use this step to write the rate of the reaction. So the rate of the reaction will be equal to the rate of the slow step. So if we know how to write the rate of the slow step, and we said that each step will be considered as elementary step, we can write it that K or R equals to K times the reactant. So if you write the rate of the slow step, it should be equals to the rate of the reaction. Okay, so this will give us two requirements that we can just verify each mechanism and see if it's valid or not. Okay, so we have two steps. The first one, we should add all the steps or the elementary steps for this mechanism. And if we add all the elementary steps together, and it will be, we will reach to the overall reaction or find the overall reaction. So this should be the first requirement done. So we will add all the reaction, like, or A will give C and C will give B. So this is the first step and this is the second step. So we will add these steps together. And then again, remember that if we find a substance that will be found as a product and the reactant, we can cancel this one out. So we will cancel C. So the overall reaction will be A equals to B. And this is the overall reaction. So this is the first requirement. The second, we said that we can write the rate for each elementary step. This will be R1 and this will be R2. If you found that the rate of the slow steps, you will write the slow step, which one is the slow. If we find that the rate of the slow step is equal to the rate of the reaction, so it means this mechanism is valid. Okay, let's see examples. Okay, what we have here? We have, this is the overall reaction, which is NO2 plus CO equals to NO plus CO2. And for this one, we have the rate law. This is the rate law of the reaction, K times NO2 to the power of 2. The proposed mechanism for this reaction is this mechanism. So we need to see if this mechanism is valid or not. So we will go for the two requirements. The first one, we need to add the steps. And if we add the steps and define the overall reaction, so this is the first requirement to done. So add them, we will try to find first which substance can be canceled out, and to cancel any substance out, so it should be found in two different parts as a product and as a reactant. So we will find that NO2, yes, we have N1, NO2, so we can cancel one of the NO2 here. NO3 and NO3, so we can cancel this one out. Actually, okay, this is done. So NO2 plus CO. So I will write all the reactant in this side and then the arrow here and start to write the other side here, what we have CO and CO2. Okay, this is the overall for the steps. Let's just check if it's the same as the overall for the reaction or not. Okay, so NO2, yes, NO2, CO, NO. So yes, this is the first requirement done. We will go for the second requirement. What is the second requirement? We will search for the slow step, the rate determining step, and we will write the rate for this step. If it's equal to the rate of the reaction, so this is the second requirement done. So this is the slow here. So the rate for this one equals to K times the concentration of the reactant. Okay, we have two reactants, NO2 times NO2. It means NO2 to the power of 2. So the rate equals to K times NO2 to the power of 2. Yes, let's check here. Yes, actually it's the same. So it means this mechanism is valid. Okay, let's see another one. Okay, we have a long one here. Okay, we have overall reaction. This is the overall reaction. 2x plus y equal to z. This is the overall reaction. And we have three proposed mechanisms. But the rate of the reaction is found to be first order in y and the zero order in x. So it means R for the reaction equals to k times y to the power of 1 and x to the power of 0. It means power 0, so we can cancel this one. So it's k times the concentration of y to the power of 1. So this is the rate of the reaction. Okay, so now we have three proposed mechanisms and we want to choose which one will be more consistent with this reaction. So we need to actually search for the two requirements. The first one, we will add the steps for the mechanism, and if we found the overall reactions, this will be the first requirement, and then we will write the rate for the slow step and should be equal to the rate of the reaction. Okay, let's start with the first one. Okay, I will try to add this one out. So it means M will be cancelled. Okay, X will not be cancelled because they are in the same place. They are all reactants. It will be 3X equal to Z. Oh, actually, this is not the overreaction, so this mechanism is not right. Okay, we'll go for this next mechanism. These the two reactions here. I will add again them so we can cancel M out. So it will be X plus Z equal to, sorry, X plus Y equal to Z. Okay. Well, actually, again, it's not right because we should have a coefficient 2 with X. We don't have a coefficient here. So again, this one is not right. Okay, we'll go for the third one. Okay, I will try to add here. We have three steps. So M will be canceled and N we can cancel. We have two intermediate here, N and M. So it will be Y plus X. We have 2X in the reactant. So it will be 2X equals to Z. So this is the reaction here. So let's check. Yes, actually, yes, it's the same of the overall. We will go for the slow step. This is the slow step here. And we will write the rate for the slow step. So the rate for the slow step, it will be equal K times the concentration of the reactant. We have only one reactant here, which is Y, so times the concentration of Y. And again, this one is the same as the one or the rate of the reaction. So this mechanism or the third mechanism is the more consistent with this reaction.